Now there's some special sets of numbers that sometimes we'll consider. The first one, sometimes we'll need to kind of limit our set a little bit to what is called a universal set. The universal set will just be the set of elements under consideration at a particular time or in a particular problem. And for obvious reasons, then, yeah, we would use a U for that. But like I said, it's just the set of all elements under consideration. And so, you know, it might be the universal set, maybe the numbers 1 through 10. Or it may be the letters A through J, or something like that. It's just something that is picked out to be the set of elements under consideration. Okay? Now, kind of on the flip side of that, then, we have the empty set, or null set, which that one may be more familiar with that one. You may have seen that one before. But yeah, the empty set is just like the name sounds there. It's the set with no elements. Null set, again, is another name for that. It has no elements at all. So if we use the set braces, yeah, you got nothing between the set braces there. Probably a more familiar notation to you is, seen this one before, right? 0 with the slash, the empty set. Use that a lot, like in algebra course, if you had a no solution, right? Well, no solution means there's the solution set is empty. So that's a specialized set also. Now, is that one, would you say that's the empty set? 0, put a 0 in there, is that okay? For the empty set? No. Why is that not the empty set? How many elements does that have? It has an element, doesn't it? 0 is an element there. So 0 in the set braces, that's not the empty set. So be aware of that. Okay. Now, also here, while we're talking about kind of the same, let's think about equality of sets. Kind of hinted at it here. That set is not equal to the empty set. But let's think about what it means to be equal in sets. And I mean, the definition is fairly obvious. Two sets are equal if they have the same elements. Okay, that makes sense. But there's some things to talk about here, though. That may not be quite what you think they should be, but yeah, two sets are equal if they have the same elements. All right, so ABC, that set equals ABC. All right, no problem there. However, think about this. DEF set, would you say that equals FED set? DEF, does that equal FED? Two sets are equal if they have the same exact elements. What are the elements here? What are the elements here? Are the elements different? Same? They're the same, aren't they?
The same.
This has element D, so does that. This has E, that has E, this is a... Yeah, those two are equal. So what does that tell you? In sets, does the order matter? No. In sets, order doesn't matter. Now, there's places where order does matter, like your phone number, but in sets, no. The order doesn't matter. We're talking about in the context of sets. The order doesn't matter. Also here. All right, so let's go with our letter. All right, so G, H, I, J. And then over here, let's go G, G, I, H, oh, I skipped H, 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 and then J, 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 J. Just kind of randomly put a bunch of J's and those together. All right. What are the elements over here? So our question is, are those two equal? What are the elements over here? Well, I've got G, H, I, J. The elements over here, I got a bunch of them, but the elements really are G, H, I, and J, aren't they? There's no other elements besides G, H, I, and J. Guess what? They're equal. Yeah. So also in sets, what else doesn't matter? Repetitions, yeah. In sets, repetitions don't matter either. In other words, repeating an element doesn't change the set. To change a set, you have to change an element. To get it to be not equal. So, yeah, if I wanted ABC and I wanted a different set, I'd have to go ABD or add more elements or something, right? GHI, and then GHI. Yeah. For it to not be equal, you have to have a different element in one place or the other, right? Either an element different or an element left off, okay? That's how sets are not equal. You have different, some sort of difference. But if they're in different order, you have them, that's still the same set. Or if you have repetitions, only repeating the elements, that's still the same set, okay? Now, that also brings up then our, let's talk about the size of sets. It's called the cardinal number. The cardinal number, what we mean by that is just the number of elements in a set. Cardinal number is just the number of elements in a set. So yeah, I mean, pretty straightforward. You just, here, well, set ABC, that has 3 elements, so its cardinal number is 3. Okay. Not that hard. It's just called the cardinal number. All right? Now there is a notation for cardinal number, and that is this. So if we have a name set, the name inside here, so the N parentheses A, that means the cardinal number of A. In other words, the number of elements of A. Okay? So N of A is the cardinal number of A. I don't remember. What the sets I made up. All right, so let's just make another. All right, so D is say D is the set where you got 1 through 17. Well, what is this then? Just cardinal number of D. It's just the number of elements of D. It's got 17. All right, 17 elements. Now, sometimes you might have to think a little more. Let's say set E. 3, 6, 9, dot, 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 till we get to, make it too hard. 36. All right, what's your N of E there? Well, you have to fill it in.
36.
Well, now we're skipping ones, aren't we? We go up to 36, but we're only doing the 3, 6, 9 one. So one way would just be to write out 3, 6, 9, 12, keep the pattern going, right? You could just write them all out. But another way we could think, all right, so this is just multiple of 3. This is 3 times 1. This is 3 times 2. 3 times 3. What's 36? 3 times 12.
6 times 1.
So that's going to be 12 elements, isn't it? I mean, just write them out if you have to, but it's another way you can think your way through it. All right, so that's cardinal number, and again, one other one. All right, so F. Just go back to the one other thing I thought of. All right, so what's the number of F there? 101, isn't it? Yeah, because you got the 100 elements, 1 to 100, but 0, it's an element. Okay, so it counts. Just like before we said, if you put 0 in the separator, that's not the empty set. Yeah, be sure and count your 0 as an element there. It does count. All right, any questions or concerns there?